Okay, we are recording. Section 4.4, counting. This is the section of permutations and combinations. Okay, so you guys should remember this section. This should be fairly easy for all of you. Okay, multiplication and counting rule before we get to permutations and combinations. Example 1. Hacker guessing a passcode. When making random guesses for an unknown 4-digit passcode, put 4 blanks. 1, 2, 3, 4. Each digit can be 0 through 9. What is the total number of different possible passcodes? Given that all of the guesses have the same chance of being correct, what is the probability of guessing the correct passcode on the first attempt? So the first digit could be how many different numbers? 10 different numbers could that first digit be, right? 0 through 9, that's 10 numbers. How many numbers could the second digit be?
10 as well.
10 as well. And third one is 10, and the fourth one is 10. Now, if they say that you cannot repeat, how does that change it?
10, 9, 8, 7.
Yep, 10, 9, 8, 7. Okay, so this is just 10 to the fourth power, which is 1 with 4 zeros. Okay, so there is 10,000 total passwords possible. 10,000 total passwords. What's the chances of me getting it correct if I randomly guess? 1 out of 10,000. So be careful on your homework assignment which one they're asking for. If they're asking for the number of combinations versus the probability. One is this answer, one is this answer. Be careful. Okay? The factorial rule. Let's go down to example 2. Factorial rule. A statistics researcher must personally visit the presidents of the Gallup, Nielsen, Harris, Pew, and Zogby polling companies. How many are there?
1, 2,
5 companies. 5 different companies. Okay. How many different travel itineraries are possible? How many different travel itineraries are possible? Okay. So that means 1, 2, 3, 4, 5. How many of those companies could I visit in my first stop? This is like my first stop.
5.
First stop. I could visit 5 different ones. Now that that one is selected, I could visit 4 in my second stop. After that one is selected, I could visit 3 in my third stop, or 2 in my fourth stop, or 1 in my fifth stop, right? And that one you can type into your calculator as 5 factorial if you want, because it goes all the way down to 1. 5 times 4 times 3 times 2 times 1 is something like 120, I think. Okay? Find the factorial button on your calculator. Okay? 4, if you have a calculator like Colton's, hold yours up, Colton. All of the stuff is going to be under the PRB button, which is right below the second button. No, it's like the second one over, the second one down, if you have a calculator like Colton's. Factorial will be under there. If you have a graphing calculator like Tori's, it's under the math button. If you have a calculator like Holly's, it will be on the main screen, I'm pretty sure.
Yeah,
It's a shift though.
X to the minus 1.
Yep. Okay. Find that button, type in 5 factorial, see if you get 120. Okay?
120.
Where's not on this one?
It's under the math button. So go math and then go over to PROB and it's right there. Okay? Anybody else can't find it?
I got it.
You got it? Perfect.
No.
You betcha. Okay? Alright, if the itinerary is randomly selected, what is the probability that the presidents are visited in order from youngest to oldest? How many combinations are there where they are youngest to oldest? 1 out of 120. That's just representing it as a probability. 1 out of 120. Good? Yes? Okay, now, does order matter for permutations, combinations? In which one does order matter? Permutation or combination? Permutation, how can you remember?
President.
Permutation is president. Write that off to the side. President. When you are doing things like president, vice president, secretary, the order in which I choose you matters, right? Because you want to be the president, not the secretary. Maybe you don't want to be any of them. I don't know. Combination, I tell you, use the word committee. ITTEE. Okay, they use position for permutation. I use president for permutation, whatever. And then we both use committee. So combination is committee. All right, the things that you need to know are what the N is and what the R is. What do those things stand for? N is the total number.
And
R is the,
I don't remember.
what's the R? No?
We Remember, what is it?
R is the number of items you're choosing, or number of people that you're choosing. So the number that I'm looking at, so it says, how many ways can I pick 3 kittens out of a litter of 10? I'm picking 3, choosing 3. R is my 3. Okay? All right, here is the formula for permutation. I'm not going to make you do that. You just use your calculator, because there's no way of me preventing you from using your calculator. So we're just going to do that. In a horse race, a trifecta. Has anybody ever been to the horse races in Grand Island?
Yep.
Yeah? Yeah? Have you bet before, like your parents bet?
I bet $5 and won 15.
Yeah. Okay, so you do have a spot there? Nice. A trifecta
Whoa, man.
bet is won by correctly selecting the horses that finished first, second, and third place. And you must select them in that order. Okay, so a trifecta equals first, second, third in that order. You have to get them right. There is like if you box it, I think, or something, you just have to get first, second, third place. Those 3 finish in the top 3. So there's a difference between these 3 finishing in the top 3 and me selecting this first, second, third in that order. Okay? The chances of me of selecting them in the order is a lesser chance, so I'm going to win more money by doing that if I win, right? If I just select these 3 are going to finish top 3rd in any order, that's not going to give me as much money if I win. It's still going to give me a lot of money, but not as much money. So how many different trifecta bets are possible if I have 19 horses? Okay, so let's determine N and R. N is how many?
N is the total.
It is 19.
N is 19, R is
You want
3. 3, and they have to finish in that order. So we do 19 P3 because this is a permutation, order matters. 19 P3. Find that on your calculator. It's around the same area as your factorial button. 1,814?
No,
5,814.
No, I don't see my thing.
Is that right? 5814?
Yes.
Yep.
Wait. So, like, do I have to type in 19 and then hit the
Yes,
NPR thing?
correct. You have to type in the 19 first. 19 P3. Check it. Make sure you know where that button is on your calculator. Okay, some of you guys it's on the main screen, some of it's under the math button.
5814.
For this one,
Okay.
it's under the multiply sign.
So do I have very good chances of getting these horses right if I randomly select them?
No.
No, now, it's not quite 1 out of 5814 if I go by like who's been doing better in previous races, right? That takes a little bit of the randomness out of the equation. Does that make sense? So if I go by like, I know this horse isn't going to place top 3 because it sucks, right? I know that this horse is going to be pretty good, so I'm going to place it here. That's not random anymore, okay? But if I randomly select them, I have a 1 out of 5814 chance of selecting them correctly in that order, okay? So it's going to win me big money. If a bettor randomly selects 3 horses for a trifecta bet, what is the probability of winning by selecting this one to win, Commanding Curve to finish second, and Danza to finish third, as they did? What's the chances of that happening? 1 out of 5814. Okay. Do all of the different possible trifecta bets have the same chance of winning?
Yes.
Yes. If you do it randomly. Ignore dead heats in which horses tie for a win. Yes, all of them have the same chances of winning if it's done randomly. Okay, let's go down to when some items are identical. Okay, there's a different rule that you use when some items are identical. So I remember doing this in geometry when we spelled the word Mississippi. Okay, Mississippi. Okay, we are taking those letters. There are 11 letters. And we are chopping them up and putting 1 letter on each card and putting them in a hat. And I want to randomly draw them out and spell the word Mississippi exactly. Right? Spelling the word Mississippi exactly. Probably not going to happen. Right? Because it's a very, very slim chance. But let's say I just so happen to do this. Okay? Let's say I draw the M first and the I second. And this S third and this S fourth and this S fifth and 6, 7, 8, 9, 10, 11. I didn't necessarily draw them in order because I switched these 2 S's around. But is it still going to spell the word Mississippi? Okay, so what I have to do is because the S's and the I's and all that stuff is because they repeat, I have to do something different. And it looks like this. We take n factorial, which is what in my Mississippi? 11 factorial, and I divide by, these are the repeating values. Repeats. Okay? So what letters repeat and how many times do they repeat? I repeats 4, S repeats 4, P repeats twice. So I have to divide by 4 factorial times 4 factorial times 2 factorial. Okay? Now, if you type this into your calculator and do this, 11 factorial divided by 4 factorial times 4 factorial times 2 factorial. If you do it that way, it will give you the wrong answer. Because all it will do is this part, then it will take that and multiply by 4 factorial and 2 factorial. So if you're going to enter it in like this into your calculator, you need to make sure you put parentheses around that bottom part. Okay, that's really superly important. Put parentheses around it. Okay, tell me how many combinations there are spelling Mississippi, or combinations there are. What?
I got the same thing.
You got the same thing?
3, 4, 6, 50.
3, 4, 650?
Yeah.
34,650? Anybody else?
Yes.
Everybody else get that too? Did you use parentheses?
Parentheses.
Yeah.
Parentheses.
So maybe yours is just an awesome calculator. Now, does yours do a fraction? Yep. So you're fine. Okay. If it puts it out as a long like list or whatever, then you want to make sure you use parentheses, but you're okay by doing
You
just the
say
top and
this
bottom.
number?
Because you can obviously tell that the bottom part is the whole line.
34, 650.
34,650, yep. Okay, so that's that many combinations. All right, let's go down to example 4. When designing surveys, pollsters sometimes repeat a question to see if a subject is thoughtlessly providing answers just to finish quickly. So what they will do, they do this, I bet you guys have had this done to you before if you've answered a survey. They will ask you the same question twice in the survey. They'll ask you, like, the first question might be really similar to the 12th question, but it's worded differently. It wants to see if you're answering them both the same way or just going through and slapping answers down, right? If it's an opinion question, okay? For one particular survey with 10 questions, so n equals 10. 2 of the questions are identical to each other, and 3 other questions are identical to each other. So we call that N1 and N2. There are 2 questions that are repeated, or excuse me, there's 1 question that's repeated twice, and 1 question that's repeated 3 times. Do you see how that works?
Yeah.
So I have 2 repeats, and I have 3 repeating the same one. For this survey, how many different arrangements are possible? Because I'm basically repeating the same question twice. So how would I do this?
Well, you go
10 factorial.
10 factorial over 2 factorial times 3 factorial. Now, sometimes it might be faster just to do some of this stuff in your head. Like 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, right? So 2 times 1 is 2. 3 times 2 times 1, that's 6. 2 times 6 is 12. So take 10 factorial and divide by 12. Rather than having to go back through and insert the factorial button in there. 10 factorial divided by 12.
I got 302,400.
Wait, what?
302, 400.
302,400. Okay. So that is how many possible combinations there are. What?
Can you answer this?
Just wait.
Could be important though.
302,400. That's how many different surveys are possible. Is it practical to survey enough subjects so that every different possible arrangement is used? Would you survey that many people?
No.
No. I would probably only use like maybe 50 different combinations max of the survey and survey maybe 1,000 people. Okay? So, I would not survey this many. You're not going to use all the combinations. Not all combinations will be used. That's a lot of people to survey using different whatever.
Since we're on probability, Cominger,
What?
let's do the probability of you dying
Of me dying
from COVID.
from COVID? They've already put the
we don't
stats
care.
out there.
But I want to see you do it. So I know
Yeah,
it's
we want to see
legitimate.
how you would figure out the
So I know
probability.
it's legitimate.
I don't know. I don't know what all
Like,
goes into that.
like,
people our age, odds on zero, so why are we wearing masks?
I don't know.
Yeah, didn't Tori look this up? It's 0.0.
Yeah, it's like
From the
0.0003
CDC.
or something like that.
But why did that?
As a percentage, it's not
Well,
even a decimal.
you know what?
Percentage.
So
Why did those people die?
So I understand like the whole like you don't. The chances of one of you guys in here getting COVID and dying is like
It's my body,
slim
it's my
to none.
choice, why do I have to wear a mask?
But the deal is like
What about like Reese Malati?
like just getting sick. Like I don't want to get sick if I can prevent it, right? So I'm gonna wash my hands. I'm gonna do what I'm supposed to, whatever.
Well, we don't have to wear masks during flu season.
I don't think it's gonna.
What?
That's airborne too.
Right. But it's I think the contagious like the rate of contagion for COVID is a lot higher than the rate of contagion for influenza, even though influenza actually kills more people than COVID. I don't know.
Exactly.
So I think what they're trying to do is not, by wearing the mask, they're not trying to keep us from dying. They're trying to keep us from having to stay home sick, is basically what I get at.
Okay, I'd
Now,
rather
I'm
get
not
it
saying
and
one
get
is
it
right or
over with.
wrong. I'm not trying to defend
And then you
their
wait 3
whatever,
months to get it again.
but they're trying to keep us in school right now, which I am all for. I want to be here
Why?
because being home is a
On the
lot more
For
painful.
as long as
Wait,
football
so
season
much
keeps
to do.
going,
Whatever.
then
if
yeah, I
you're
wanna
at
be
home,
here.
You don't have to pay for
We're
daycare,
actually
you
gonna do
can just
work
like
though,
bring
for
it.
No, you still pay for daycare even though you
We'd
don't
actually
go.
have to do work.
Then I'd actually have time
I
for
actually do.
scholarship.
All right, last one.
Alright.
Kind of, almost.
Friends.
Combinations, NCR. Rules still apply except combination, no order. Order doesn't matter. Okay? In California's Fantasy 5 lottery game, winning the jackpot requires that you select 5 different numbers from 1 to 39